This is part 2 of the QuakeClamp story. We continue to look for ways to increase holding capacity in all directions while maintaining the simple to install and adjust features of the basic QuakeClamp. This is taken from Kinetics documents. Beam clamps without retainer or safety straps, even with a pointed set screw, these devices rely strongly on friction to hold their position. If a retainer/safety strap is used with a beam clamp to mechanically prevent it from walking off the beam under a cyclic load, and the strap is of adequate size to resist the expected seismic load, then it may be used to anchor the seismic restraint to the structure. Kinetics trademark. From Kinetics. Chapter 13. Seismic Design Requirements for Non-Structural Components. ASCE 13.4. Component attachments shall be bolted, welded, or otherwise positively fastened without consideration of frictional resistance produced by the effects of gravity. A continuous load path of sufficient strength and stiffness between the component and the supporting structure shall be provided. Local elements of the structure including connections shall be designed and constructed for the component forces where they control the design of the elements or their connections. ASCE 13.4.6 Friction clips. Friction clips shall not be used for anchorage attachment. While our QuakeClamp fills the needs written by Kinetics, we continue to develop ways to improve the QuakeClamp by reducing longitudinal and transverse sliding. The normal limit to what the QuakeClamp will hold is governed by the strength of the strut channel and the longitudinal slipping of the clamp on the beam. While the QuakeClamp performs well for normal use, we have found two ways to reduce slipping on the beam flange. First, a set screw in the middle of the hook area can be added to increase the force that causes sliding to 3,200 pounds. Second, a weld bump can be placed on both edges of the beam flanges located to provide stops for the edge of the clamp body hooks to bump against. These options provide advantages for struts attached to sloping or vertical beam. They are also recommended in environments where shaking and vibration are possible. A new capacity now available that is not otherwise available, except by welding struts to I-beams, is to attach struts to vertical beams using our QuakeClamp. The QuakeClamp will hold greater cantilevered forks than the strut channel can sustain without bending. We can do better. The normal limit to what the QuakeClamp will hold is governed by the strength of the strut channel and the longitudinal slipping of the side of the clamp on the beam. We have found two ways to reduce slipping on the beam flange. These methods are the same as shown above in reference to longitudinal forces. We have found many ways that the sliding of the strut channel can be reduced or completely stopped. The simplest method is to use a standard strut nut, 1 or 2 square flat washers and a bolt. They are positioned against either side of the clamp. This will work either against the bolted flange or against the hook. This significantly reduces sliding while using common components. We are developing and testing a family of U-clip hangers and bolt extension clips that will provide a number of more useful options. The QuakeClamp is stronger than the strut channel. In most situations the clamp is not what fails. We see greater use for the QuakeClamp system in the future beyond just hanging strut channels. This is why we continue to look for ways to increase its capacity and function. The newest innovation to the QuakeClamp system is the hanger clips. In the simplest form, it is a flat strip of steel that has notches to engage the inside of the strut channel. It has a hole that lines up with the center bolt connecting the two sides of the clamp together. It has another hole that loads can be attached to. One clip will hold approximately the full load of one side of the clamp assembly. They can be attached to both sides of the assembly or sandwiched together to entrap a flat surface being supported. Here are some examples of U-shaped hanger clips. They function basically the same as the single clip. They can be anchored to the clamps in similar fashion but can be located independently at a carriage bolt. A washer and a nut are added to the middle as a way to hold them in place. This product also works to hold the entire assembly in place. If placed in between the clamp bodies, it allows two short bolts to be used instead of one long one. Shown are several examples of simple hanger clips that get attached to the QuakeClamp. They all attach inside of the strut channel captured to the outside of the QuakeClamp by the bolt or bolts that hold the two halves of the clamp together. Because the clamp bodies entrap the strut at the mounting point, strut failure is prevented. Each one will hold the whole load of the side of the clamp they are attached to. As was previously said, if U-shaped hanger clips are placed in between the clamp bodies, it allows two short bolts to be used instead of one long one. It is also possible to use a long piece of threaded rod to make unique configurations. Also shown is a U-shaped clip that has teeth to provide greater gripping to the strut channel. On the bottom side of the beam, a threaded rod along with nuts and washers is used to attach the hanger clip and create a threaded hanger rod. This U-shaped hanger clip allows for either a threaded rod to connect, or can be used to support a second strut channel in line with the beam. One side needs to be secured to the outside of the clamp, but the whole U-clip can be on the outside of the clamp assembly as well as on the inside as shown. Strapping configurations are flexible. They are shown attached to one side of the beam. They also can be attached to clips on opposite sides of the beam. This is a good method for hanging a variety of shapes and sizes of loads. This also provides a basis for attaching some types of bracing. We have clamps for 3 flange thickness sizes. There is a range of flange thicknesses for each size. The flange thickness they each work with overlaps. All 3 will actually work on a middle thickness of I-beam flange. Identification holes are placed on the flange so an installer can quickly identify the size in hand. Many installations require the higher capacity. The double, or back-to-back, strut channels provide the solution. QuakeClamp has been testing and perfecting the QuakeClamp that is sized to hold the 1.625 inch by 3.25 inch strut channel. Like with our original QuakeClamp, there are 3 sizes that can be used. The load on the connecting bolt is very low. Any 3/8 inch bolt will work. Square holes are placed in the clamp so carriage bolts are a good option. 1 or 2 bolts can be used. Using 2 bolts are best for reduced sliding. During testing it was found that the nuts can be tightened from 5 foot-pounds of torque to 15 foot-pounds and still allow the clamp to hold over 11,000 pounds. The preferred length is about 1 inch less than the width of the beam. Let's do a quick review for why QuakeClamp should be used. First is safety. Load capacity. Less musculoskeletal stress. Positive connection, seismic applications. Reduced falling object hazard. Easy adjustment. Second is versatility. Hanger assembly options. Simple trapeze hanger. Inline options. Vertical possibilities. Third and most important is the saving of money. 1 bolt assembly. More accessible design. 1/4 the installation time.
Hi, this is Phil Myers again. I am back to thank you for taking the time to watch this presentation. I hope you have seen the possibilities that QuakeClamp products may offer you. Let me know if more information is needed. If you need, I can provide test results in Excel format. These include graphs for comparing different tests. If you need drawings to include in your design, let me know the format needed and what you are trying to accomplish with them. You can call me or send me an email. We are ready to include new customers and distributors into our supply chain. Feel free to pass this presentation on. Thank you.